So yesterday we finished off with question number 14, which was, how do we do this? It asked for what type of a quadrilateral it is. I think we just sketched it, right? And it turns out it looks something like this. Let me just plug in my pen. What's the difference between a trapezoid and a parallelogram? Listen this. Parallelogram, all sides are, well, not all sides, but this side is parallel with this side. This side is parallel with this, right? That's a parallelogram. Trapezoid, on the other hand, only two sides are parallel. The top, which is called A, the bottom, which is called B. These two sides here on the side, they don't have to be equal. They don't have to be parallel, okay? So this question, I think what we did was we just straight up graphed it out and we saw something like this. So that pretty much eliminates parallelogram, rhombus, and a rectangle. That's why it was a trapezoid. If we really wanted to, we could have found the slope here, which I'm gonna call MA, the slope going this way, using this point and this point. And we could have found slope B going this way, the same way. How are these two slopes related if they are parallel? If the slopes are parallel, sorry, if the lines are parallel, the slopes are equal. So if we found this as 2/3, then we would also expect MB to be 2/3. So that's how you can show something as parallel. This next question is a tricky one. It says we have an arch. What's the radius of the circle? There's options there as well. What do you think the answer is? They have given us some information and they're asking us for the radius. Is it 0.75?
No.
No, right? So what is it then? You have four options there. 3 would be the diameter because it expands throughout the circle.
So it's A?
It's A, right? So, but what's going on with this 0.5? Well, that's not the radius. The radius is this here that expands all the way to the top of this circle. This is the actual circle. Okay, it looks something like that. And what's the radius of this inner circle? The inner circle would be 0.75. So they've given us a quadratic, and then they've given us two x-intercepts. The second differences are negative. So if the second differences are positive, it opens up. If the second differences are negative, it opens down. So our two zeros are at -5 and +4. Second differences just means you subtract the y's twice. And if the second differences are negative, then you're gonna be opening downwards like this. So which statement is true about this? Is that a maximum or a minimum?
It's a maximum.
Right, is that coordinate positive or negative?
Positive.
Positive, so it must be option 1. When you're talking about the max and the min, you're always talking about the y value. So up here, the y value is positive. So another, you have a quadratic, a value is 3, means it's opening up. And they've given us some points, -2, 7. And they've given us 4, 7 as well. And it's asking us for the vertex. Now remember, the vertex, you can find the h value of the vertex by finding the midpoint of the x-intercepts or any other coordinate where the y values are equal. Over here, they've given us this coordinate and this coordinate, right?
Mm-hmm.
The axis of symmetry, it's called, wherever the vertex is, the x value of the vertex is going to be exactly in the middle of these two x values. What's the midpoint between -2 and 4?
It's 1.
It's 1, right? So we know h is 1. If you have h, how do you find k?
You plug h in.
Yeah, you plug h in. So if you plug h in, you get 3 times 1 squared minus 6 times 1 minus 17. So you get 3 minus 6 minus 17. -3 minus 17 is -20. So that means k must be -20. So which option is correct? We have h as 1 and k as -20.
B.
B is right, yeah. They've given us the zeros, which is just the x-intercepts, and they have also given us another coordinate, 0, 5, that's the y-intercept. They've given us the x-intercept and the y-intercept. They want us to find the equation. Which form of the quadratic works best if you have the x-intercepts?
Factored.
Factored, right? Now we just got to plug it in. So this is the general form. You have an a value there. If you plug in the two x-intercepts, what does this become? If you plug -1 in there, what does it become? Becomes +1. 5 becomes -5. Now to find the a value, it looks like it's gonna be 1 because none of them have any a values. To find the a values, you just plug in that coordinate as x and y, which here we'll see that it's gonna be 1. So you get -5a is equals to -5. That means a is 1. That means this is our answer. Y equals x plus 1 times x minus 5, which is option B. And we are done. Here we're given the thing in factored form. And what do they want? They want us to find the maximum. Okay, how do you find the maximum when you have the factored form of the quadratic? So basically we need to go from factored form and find k. To find k, you first need to find h. What are the two x-intercepts here? You see this is in factored form. We need to find the x-intercepts. You just flip the sign. I'll give you
-78 and -3.
-3 is right, but not -78 because what we're doing technically is this. We're setting it equal to 0. To find the x-intercepts, you want to set y as 0 and solve for it. The -3 we would get like that, but the other one, it's not going to be -78. It's going to be -78 divided by -6, like that. So -78 divided by -6, which is 13. So our two x-intercepts are -3 and 13. Now, next we need to find the h value, which is basically the midpoint between -3 and 13. What's
It's
h?
5.
It's 5, exactly. How do you find k? Plug it
You
back in,
plug
right?
h into the equation.
So we get this, and then we get 5 plus 3. Let's plug that in. So -30 plus 78 times 8. I got 384. So k is 384, but this is in thousands of dollars. So 384,000. So that's the k value, which is option C. And we are done. Alrighty, they've given us the factored form of a quadratic, and they've given us the zeros. And they've also given us the point, and they want us to find the value of a. Very simple. You just plug the x-intercepts in there and solve, and then you plug the point in there and solve for a. Like that, and then what's our point? Our point is 524. So the y value is 5. Sorry, it's 24 when the x value is 5. I messed this up, didn't I? Yeah, I did. So these are our x-intercepts. If we plug this in, this becomes x plus 3 and x minus 7. Next, we're going to plug x as 5. And what is this going to become? This is 8 times -2 equals 24. This is -16a equals 24. It's going to be 24 over -16. Now, if you reduce that, what do you get? 24 over -16.
Three over 2.
Yeah, -3 over 2, which is option C. Are we expecting this to open up or down?
Open up.
Well, a value is negative, right? -3 over 2. It's going to open down.
Mm-hmm.
And that's it. Very similar question here. They've given us the two x-intercepts, so straight up let's plug them in. X minus 16, x minus 28. And it goes through 32, 16. So the y value is 16 when the x value is 32. Like that. So it's 16 equals a times 16. This should have been 28. A times 16 times 4. So 16 and 16 cancels out. A is 1 over 4. So which option is right here? A is
D.
1 over 4. Yeah, it's gonna be D. And that's it, easy. Which expression is the product of these two terms? We have two terms here. We have two terms here. When you multiply them, first step, you're gonna get 4 terms. We're basically just gonna FOIL this. It's not difficult. So first we go like this, 3x with 7x, 3x with 6, and then we go -4 with 7x, -4 with 6. What's the first term?
21x squared.
Yeah. What's the next term?
18x.
What's the next term?
negative 28x squared.
No x squared, just negative 28x, because we're doing negative 4 with 7x.
Mhm.
And then lastly, you'd get minus 24. So 18 minus 28 is negative 10. So we're looking for the one with negative 10x and 24 minus. So it's going to be option D. That's it for that. Easy peasy. (23) You have a fraction with a negative exponent. What do we do with negative exponents? If you have negative exponent in a fraction, you flip it, okay? Becomes 9/4, and the exponent becomes positive like that. Keep that in mind. So what's the answer here? A, B, C, or D?
It's B.
Yeah. What's the answer to 24?
D.
Yeah. What if it was negative 5 to this power of 0? What would be the answer?
It's still 1.
It'll be negative 1. It'll be 1 if it's like this. This is 1, whereas this one, the 0 does not apply to the negative sign. This will be negative 1.
Mm-hmm.
That's it. The next part is pretty simple as well. We're just factoring things. Let's see if there's any interesting topics here at all. So this is just GCF, right? We're just factoring out GCF. They've done it with tiles, but that's not really practical. I'm gonna ignore that, because no one's drawing like 20 tiles to pull out nx squared. Here, A, what can we pull out? Which basically means, what's the GCF?
5a squared.
Okay, then what are you left with? So that's right. If you pull out a 5a squared, what are you left with inside the bracket?
2a minus 5.
Yeah, that's it. Easy peasy. What about B? What can we pull out here? This one's a little bit trickier. What's the GCF between 9, 12, and 6? Just the numbers.
3.
3, right? Between x4, x3, and x2, it's gonna be x2. y4, y2, and y3, it's gonna be y2, because you can't pull y3 out of y2, but you can pull y2 out of y3. So that's our GCF, 3x2, y2. The first term here, well, we're pulling 3 out of 9, so it's going to be 3. We're pulling x2 out of x4. What are we left with?
X squared.
Yeah, The same thing with the y. So 3x squared y squared is our first term. What's our second term?
X.
Yeah. What about our last term?
Y.
Yeah, and that's it. That's the GCF. This one could be a little bit tricky. For A, is there anything we can pull out? Or do we need to open the brackets?
You open the brackets.
No, you don't have to open the brackets. Here, if I asked you 5x times A minus 3 times A, if you pull out an A, what are you left with?
5x minus 3.
Same idea here in this question as well. We're gonna treat these brackets, x minus 2 as our A, okay? So what we do is we pull out that entire bracket, x minus 2. What are you left with in the other bracket? It's very similar to this.
5x minus 3.
Yeah, 5x minus 3. You could open the brackets and try and man it, but that's just extra steps. If you have brackets that they both have that are exactly the same, you can pull that bracket out. What about in B? What can we pull out from the first two terms?
A.
We can pull out an A. What are we left with?
X minus y.
Right. What about the next two terms? What can we pull out?
5.
Okay, what are we left with?
X plus y.
So ideally what you want to have is you would like for this bracket and this bracket to be exactly the same. So you can pull them out like we did in the first question here. So no, the other bracket there is not going to be x plus y. What we should do actually is this sign is always going to drop. So we're actually pulling out -5. If you pull out -5 from -5x, you're left with an x. And if you pull out -5 from +5y, you're gonna be left with a y.
Mm-hmm.
So x minus y. Next, we're gonna pull out that entire bracket of x minus y because they both have that in common. What are we left with in the other bracket?
A minus 5.
Yeah, and that's it. Not a whole lot going on here. We could try doing this. So we have a trapezoid and they've given us the area. We want to find the height. What's the formula for an area of a trapezoid? You remember we talked about this yesterday briefly and even earlier today. Trapezoid, what's the area? Is it length times width?
No.
No, it's not. What is it? It uses A and B.
A plus b over 2 and then times the height.
Yeah. So here we know what the area is. Area is 70B plus 10. What's our A? A is the side length of the top part, which is 4B plus 1, right?
Mm-hmm.
Plus, what's our base here?
3b.
3B divided by 2 times H. How do we solve this for H?
You multiply by 2.
Yeah. What next?
Can you add the 4b and 3b together?
Yeah, you can because they're like terms. What's next?
You subtract 1.
No, you cannot subtract 1 because you're multiplying h.
So you divide
Yeah,
by 7b plus 1.
yeah. Now this one's a little bit tricky because that's gonna be exactly 20, I think. So you have 7b plus 1, and your dividend, the guy that you're trying to divide, the bigger number there, the numerator, is this. How many times does 7b go into 140b? It goes
20 times.
20 times. So then maybe this is not doable. 7b times 20 is 140b, and then plus 1 times 20 is plus 20. You know, you get a remainder of -10, so that's gonna be the final answer. I was hoping it would be exactly 20, but it's not because there's a remainder. So this is called long division of polynomials. Not really part of this course. So here we're given two parabolas, which just means two quadratic equations. And we need to find the distance between their max and their min values. A little bit tricky. How do we approach this? I always like graphing my quadratics. So let's factor out an x. So there's 10 minus x in the first guy. The second guy, what can we pull out? In this equation, what's the GCF?
3x.
3x, yeah? And you're left with x minus what?
10.
10. What are the x-intercepts for this? To find the x-intercepts, set them up individually equals to 0. The first one, you set this equal to 0, well, x is just 0. Next, you set 10 minus x equal to 0. What would x be here if 10 minus x is 0? X is plus 10. Same thing here. If you do this, you're gonna get x is equal to 0 and x is equals to 10, which means the h value is 5. The k value, now you need to plug 5 back in there, so you get 5 times 10 minus 5, so that's going to be 25. Plug 5 in there, it's going to be 15 times -5, -75. Now when you go to graph it, the first one, 0 and 10, and then your vertex is at 5 and 25. So up here, this is the first graph. The next graph, we have the same x-intercepts, but then we have a minimum now because it's opening upwards. And the minimum is at 5. That still stays there, but now it's at 75. -75, sorry. It's going to go through the same x-intercepts because the x-intercepts are still 0 and 10. The h value is still 5. So you get something like this. The question's asking you, what's the distance from here to here? What's the answer?
100.
100 units. There you go. If it was not symmetrical like this one, then you would have to use the distance formula, but this one is symmetrical because the x values are the same, so it's gonna be straight up 100 units. So this one, always graph it if you can, and the x-intercepts here are the same. It's not terribly difficult. So this guy says the GCF is 5x, the next guy says GCF is negative 5x. Who's right? Well, both of them are right. If you pull out 5x, right, let me just rewrite this, maybe it'll be easier. 10x squared minus 20x. If you pull out 5x, what are you left with?
Negative x squared plus 2x.
Yeah, minus 4. Now similarly, if you pull out negative 5x, you'll be left with positive x squared minus 2x plus 4, yeah? Notice how you can factor both of them. The only difference are the signs. They're both correct because you can factor either one of them out. The sign is pretty redundant, depends on what's the next steps are. I would probably do this just because it's easier to man. This one, if you man it, there's going to be one extra step. What does consecutive integers mean?
Numbers that come after each other.
Right, so it says one more than the sum of any 3 integers is always divisible by 3. Name me one integer, any integer you can think of.
Negative 20.
Alright, negative. Let's do negative 2 because the squares are gonna get big. So negative 2. What comes after negative 2?
Negative 3.
So consecutive means you can go left, but usually you go right, okay? Negative 1 and 0. Follow the number line. Now if you square them, so negative 2 squared is 4. 1 squared is 1. And it says if you add one more, you're always gonna add this extra thing. It's gonna be divisible by 3. 6 is indeed divisible by 3, okay? But you can't give examples, I don't think so, in this question. You need to kind of generalize it. How do you do that? And this is very critical here. Let the first integer be x. If the first integer is x, what's the next integer? It's just
X plus 1.
Yeah, what's the next integer?
X plus 2.
Yeah, x plus 2. So now if you square it, you have x squared. What's x plus 1 squared? X plus 1 squared.
Is it just x squared plus 1?
No, it's not. I'll show you why it's not. That's a common mistake. Anytime you have a square, that means you're multiplying with yourself,
Oh,
right? You're gonna see it's gonna be a third term here. X squared plus x plus 1. So it's gonna be x squared plus 2x plus 1. Similarly, x plus 2 whole squared. If you FOIL it, it's not gonna be x squared plus 4. It's gonna be x squared plus 4x plus 4. There's gonna be a middle term. So let's square that. So you get x squared plus 4x plus 4. And it says you need to add a 1 at the end. All right, let's add a 1. So now let's clean this up. You have x squared, x squared, x squared. So 3x squared. You have 2x plus 4x, so that's 6x. You have 1 plus 4 plus 1, that's 6. Pull out a 3. You have x squared plus 2x plus 2, right? Now, is this divisible by 3? This entire thing? Yes, it is, right? We don't care what x is. X could be like negative 20 or 3 over 5. Well, it's not going to be 3 over 5 because we're talking about integers, so whole numbers. But x could be anything there. This thing will always be divisible by 3 because if you divide it by 3, then this cancels out with this. You get this as your quotient. So that's how you can generalize it. That thing there is always going to be divisible by 3 because of this, regardless of which integers you pick. So we've kind of generalized it, and that's how you do this question. It's a little bit tricky. If you don't know this, if you don't do this, then yeah, you won't get full marks. You could give them 20 examples, but I don't know if they'll give you full marks. Because what happens is sometimes it's weird. Let's say you pick some examples here, they work, yeah? Imagine this is a number line, you have infinity up there. Pick some examples that work, you pick some examples that work, you pick hundreds of them that work. But then you only need one example somewhere up here, giant numbers that don't work. That means you can't generalize it, so the theorem is not true. That's why if you generalize it, it's going to work everywhere. But if you use examples, pure examples, there could be a set of numbers somewhere up there, like in the trillions, or numbers get big really, really fast. You might think trillion is a big number. Well, it is, but not when you consider the number line, because you can have trillions of trillions, right? You can have trillion to the power of a trillion to the power of a trillion. It gets, yeah, our minds are not equipped to handle numbers so big, but we do know it exists somewhere up there. So if one of them fails, your thing is wrong to begin with. Let's try doing this one. This one looks interesting. So we have a square and we have a circle. It's asking us to find the expression of the shaded bit. How do we start this question? What's going to be our first step?
You find the area of the square and the circle.
Okay, so what's the area of the square? What's the length?
2r times 2r.
Yeah, which is 4r squared. What's the area of the circle?
Pi r squared.
Pi r squared. You're always going to do the bigger area minus the smaller area. Otherwise you get a negative area. So we're going to do area of a square, which is bigger than, because the circle is enclosed in the square, like that. So you do 4r squared minus pi r squared. Take out a r squared, you get 4 minus pi. And that's it. That's the answer. Can this ever be negative? No, it cannot, because 4 minus pi is 3 point something, so that's always going to be a positive number. It's going to be a constant, and r is a radius. You should always have a positive radius, but in the case you get a negative radius, it's being squared anyways. Okay,
Mhm.
now can radius be negative? No, right? Generally no, but eventually what's going to happen is when we start considering quadrants and stuff, then the radius will end up becoming negative. What do I mean by this? Again, this is not this level. Let's say we have a point here, yeah?
Mhm.
Let's say that point is AB. Well, we know it's minus A minus B, because x is going to be negative there, y is also going to be negative there. And the same point up here is going to be AB if you treat this as like a circle. Now, the radius is r in both cases, right? But sometimes what people do is they'll give you a negative radius like this, which means that instead of the point being up here, it's down there. They'll give you an angle as well. This is called polar coordinates. We're not going to get into it anytime soon, but when you're taking things, we've done complex numbers, right? That's the, well, we haven't really done it, but I've shown you that I is the square root of -1, and then you get like, this is like the complex plane, and then this is like the number line, real numbers. In this mathematics, you can take the square root of a negative number. Similarly, you have something called polar coordinates, which we will do maybe if we do trig at the grade 12 level. In there, the radius can be technically negative. It just means it's a distance in the third or the fourth quadrant. This thing is just man, right? We've done so much of this. I don't know how deep I want to get with this. Okay, this one, it says factor. What can we pull out?
3y.
Just 3y, that's right. What are we left with if we pull out a 3y?
Y squared minus 7y. And then, yeah,
All right, how do we factor that? We need to man it. What does it multiply to? What does it add up to? Look inside the brackets.
it adds up to -7.
Yeah. And it multiplies to what?
-8.
Yeah, what are the numbers? Adds to -7, multiplies to -8.
-8 and 1.
That's right. Now, if the a value here is 1, you can straight up do y minus 8, y plus 1. If the a value there is 1. If not, then you would have to break down the middle guy into 8y plus 1y, and then you gotta factor 2 at a time. So from y squared and 8y, you can pull out a y. From 1y minus 8, you can pull out a 1. then you get y minus 8, y plus 1. So this is what you would do if the a value is not 1. If the a value is 1, once you have the numbers, you can straight up go to this step. I'm trying to find some interesting questions here. Maybe this one? That looks dangerous. That looks kind of dumb actually, because the water looks really shallow. Maybe it's deep, I don't know, but like here looks pretty shallow. I wouldn't do that. You don't know the issue with doing something like this. I don't know if this is photoshopped or what, because you see these rocks,
Mhm.
they are very sharp. Okay, you do not want to hit them. But the thing is, down here at the bottom, right, especially when you go to rocky places like these, coral reefs and whatnot, it's not like a beach. It's not like a perfect flat floor at the bottom of the water. There
There's
could
more
be
rock.
there's could be more sharp rocks. So this guy's gonna go in there head first. That looks very shallow, so I don't know about this. Anyways, so we're given an equation for a height, and the first question is asking us to draw a graph. All right, what can we pull out there? Negative 5t squared plus 20, what can we pull out?
-5.
All right, what are we left with?
T squared -4.
Minus 4. Can we factor t squared minus 4? The answer is yes, but you can't manage. Man is for trinomials. When you have 3 terms. This is a binomial, which has 2 terms. You remember how to factor this?
Was it like difference of squares?
It was, yeah. So what does it become? It's going to become t minus something and t plus something. It's just going to be the square root of this number. T minus 2, t plus 2.
Mhm.
So that means our x-intercepts are 2 and -2. Our y-intercept is given up here. It's always going to be the constant in the standard form. It's 20. H is going to be 2 plus -2 divided by 0. Sorry, not 0. What am I saying? 0 over 2. It's going to be 0. To find the k value, it's also going to be 20. So our x-intercept and y-intercept are the same. Sorry, x-intercept we have 2 and -2, but our y-intercept and the vertex is going to be the same. So -2, +2. Let's say that's 20. That's our vertex. That's also our y-intercept. So our graph looks, is it 20? Then how does this work? Because this should be opening down, right? 5t squared plus, oh, it's +20, that's -20. We should be up here. +20, I was in the negative quadrant. Yeah, it makes sense. So x-intercept, -2, +2, y-intercept of 20, the vertex of 0 and +20. So up there. So this is what it looks like. Now we can answer the questions. Question A, draw a height versus time graph. So on the y-axis we have height, on the x-axis we have time. That's the answer to part A. B, determine the height of the cliff that the diver jumped from. What's the answer to that?
20.
20 meters, easy. Determine when the diver will enter the water. When he enters the water,
For
the
that
height
second?
is, yeah, 2 seconds. The height will be 0 when he enters the water. Here, D, this is a trick question. Determine the height when the diver will exit the water. What's the answer to that question? The answer is we don't know, okay? Because this model, right, that we have is only fit for this. Okay?
Mm-hmm.
Just this. We don't know what happens after he enters the water. The model cannot answer that question. This is like a modeling thing we did a couple of weeks ago. But my answer is that he's never coming out of the water because there's rocks down there. But the technical answer is the model cannot answer that question. It's only valid up until this point. All right, we can stop there for today.
Okay, thank you.
All right, see ya.